Hello, Algebra 2 CP students. Hopefully you're having a great day so far. Today, I would like to spend just one more day on talking about graphing quadratic functions in standard form. I have two more examples to show you today and one for you to try on your own. Based on what we did yesterday in both my Algebra 2 classes, it seemed like that it was kind of clicking in a lot of people's minds and it made a lot of sense and it seemed pretty straightforward. So hopefully this really solidifies the whole process of graphing a function in standard form, and on a 1 to 5 scale of 1 being clueless and 5 being like if you feel like a pro, maybe this will bring those 3s up to 4s and those 4s up to 5s. At least that's the hope. So I have two examples prepared for you that I'm going to do with you and one example for you to do on your own. The rest of this week will be practicing and a progress assessment. So these will be the last ones that I'll really sit down and do with you. But that being said, let's not wait any longer. Let's get into it. First of which I have is this. Let's try f of x is equal to, f of x is equal to negative 2 times x squared plus 16x minus 25. Remember that our standard form is ax squared. It's f of x equals ax squared plus bx plus c. And to find the vertex of something in standard form, we do negative b over 2a, and then take that value and plug it into the function f of negative b over 2a. So that's exactly what I would do to get things started here. We always want to start by finding the vertex. I would say that the x-coordinate of the vertex is negative b over 2a. So in this case, that's going to be negative 16, because this is our a, b, c. Negative 16 over 2a, so 2 times negative 2. That's negative 16 over negative 4. Negative 16 divided by negative 4 is positive 4. So that's great. That's the x-coordinate of our vertex, positive 4. Great, fantastic. Now, in order to find the corresponding y-coordinate of the vertex, we can take this 4, plug it back into the function, and solve. I would say that f of 4 is equal to negative 2 times 4 squared plus 16 times 4 minus 25. Be careful with your order of operations as you do this. Remember that we're going to square first, then multiply. 4 squared is 16 times negative 2 is negative 32. Plus 16 times 4 is 64. Negative 32 plus 64 is positive 32. Minus 25, that's going to be positive 7. And so therefore, our vertex is going to be 4 comma 7. So hopefully that makes sense as to how we found the vertex of that function. Okay? That may seem like it's pretty high up on the graph, and I guess it is. But notice that the stretch, the a value of this graph being a negative 2, means that it's going to be facing down, and it's going to be going down a little steeper than usual. So at twice the normal rate. Let's go ahead and draw in my coordinate plane here. I'm going to leave a lot of room on the right-hand side because I see my vertex and I see my stretch. I kind of know where my function is going to reside on the coordinate plane. Kind of visualize that it's going to be over here. So let's make it happen. I would take my vertex, plot that on my graph. Here's 1, 2, 3, 4, 5, 6, 7. Now to see what the rest of my parabola looks like, even though we have that vague sort of mental image, I can now create a table of values and see more specifically what it looks like. We have negative 2x squared plus 16x minus 25 here. And my values for x there. The x-coordinate of the vertex was 4. And around that 4, we could use 2 and 3, as well as 5 and 6, to just get 2 points on the left and 2 points on the right of that vertex, right? And the y-coordinate was 7. So personally, I would try to plug in 2 and 3. Smaller numbers, probably a little easier to work with. You could plug in 5 and 6 if you wanted to. You'll get the exact same results. So it's entirely up to you. But I would choose the top, easier numbers. Let's take 3. Let's plug it in. Let's see what we get. We can say that f of 3 would equal negative 2 times 3 squared plus 16 times 3 minus 25. That's going to be, let's see, 3 squared is 9 times negative 2 is negative 18 plus 16 times 3 is 48. So negative 18 plus 48, I believe, is, 30? And then minus 25, we get positive 5. So it looks like f of 3 is positive 5. Our next point is at 3 comma 5. And then we can plug in 2. We would say f of 2 is negative 2 times 2 squared plus 16 times 2. We're just taking it, plugging in for x, minus 25. What do we get here? We get 2 squared is 4 times negative 2 is negative 8 plus 16 times 2 is 32. So that's 24 so far. Minus 25 is negative 1. So when we plug in 2, we get negative 1. That's going to be right here on our graph. And now we can go ahead and sketch our parabola. We know that the vertex is the center, right? So picture that this is the middle of the graph. That means if there's a point here, this far away from the vertex, there'd have to be a matching point right here. If there's a point here this far away from the vertex, or you can think of it like from the axis of symmetry, if it's 2 units away there, it has to be 2 units away here. So there's a mirror image point there. And we can go ahead and sketch our parabola. Just like that. Just like that. All right? And you can reflect the values in the chart as well. This would have to be 5. This would also have to be negative 1. Okay? Hopefully no questions on that. Just for the sake of doing it once, I will go through the domain, range, axis of symmetry, maximum minimum value, and end behavior. We'd say the domain of any parabola is all real numbers. But specifically, it's because domain refers to how far to the left does the graph go, how far to the right does the graph go. It goes to the left forever and the right forever, so we'd say it's all real numbers. The range is not all real numbers, though. It does go down forever because it's facing down, but it doesn't go up forever. It only goes up to positive 7. And notice I'm using a square bracket because it includes 7. So our range is negative infinity to 7. Let's see. We also have the axis of symmetry. That's the vertical line that we could draw, which always passes through the x-coordinate of the vertex. That splits the parabola in half. So like we could draw this vertical line right here. Cuts that parabola right in half. That's what you could use to mirror your points, by the way, if it's helpful to you, to draw in that axis of symmetry. That takes place at x equals 1, 2, 3, 4. That vertical line is x equals 4. Because all of those points along that vertical line have x-coordinate equal to 4. Next, we have our maximum or minimum value. Here, this parabola has a maximum, does not have a minimum. And we said this has a maximum at f of x is equal to 7. The highest the parabola goes up to is 7. Let's see. We also have the end behavior. That's the last one. Last but most certainly not least. Notice how the parabola is going down on both sides. As x approaches negative infinity means as we proceed to the left. As your x values get smaller, what is your y values doing? What are your y values doing? They're also getting smaller. As x approaches negative infinity, the function itself is also approaching negative infinity. It's also getting smaller. As x now gets larger, it increases as you move to the right. Your function is still going down because on this side it's also decreasing, right? If you keep going this way, picture it. If you kept going to the right, off the page here to the right, the graph would be like way down here, right? Way down where my pen is, way down here, right? And so that's the idea. Okay. Hopefully that made sense. That's a now complete parabola with the picture, the information, the chart, the vertex, everything you could ask for. All right, hopefully no questions on that. We're going to do one more, and then I'll ask you to try one on your own. Okay, let's make it happen. Let me get a fresh sheet of paper. Do this next one. Okay. Next problem. Let's do f of x. Help if my pen was clicked in here. F of x equals 4x squared minus 24x plus 27. Okay. Now, before we even do any math, you can get a good visual of what this parabola should look like by finding the vertex And also noticing the stretch. The stretch of 4 means it's going to be increasing 4 times as quickly as the parent function. So it's going to be a pretty steep looking parabola. Let's see more specifically what it looks like. I would say here that the x-coordinate of the vertex is negative b over 2a. So in this case, it would be the opposite of negative 24 over 2 times 4, which is going to be positive 24 over positive 8. 24 divided by 8 is 3. To find the corresponding y-coordinate, we'll just take that 3 and plug it in, do f of 3. Say that's equal to 4 times 3 squared minus 24 times 3 plus 27. So let's see what we get. 3 squared is 9 times 4 is 36. Minus 24 times 3, that's minus 72, is negative 36. Plus 27, negative 36 plus 27, I believe that's going to be negative 9. Okay. Again, that seems like it's kind of low on our usual coordinate plane, but considering the stretch is 4, we're going to need all that space that we can get. So we get our vertex is at 3 comma negative 9. As I'm going to sketch my graph, I'm going to leave a lot of room vertically for this graph here. That should be enough. Go even just a couple more squares, just to be sure. Should look kind of like that. Okay. Our vertex is at 1, 2, 3, comma 1, 2, 3, 4, 5, 6. Oh, I almost lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I glanced at the video timer for a second, lost count of where I was. My vertex is at 3 comma negative 9. We can now go ahead and make a table of values to see what this is going to look like. We have our values for x. We have our function 4x squared minus 24x plus 27. My vertex was at 3 comma negative 9. Let's pick a couple points around that vertex, namely 1 and 2 and 4 and 5. The reason we're going 2 to the left and 2 to the right, by the way, is just so we can get a picture of what's going on around that vertex. There's no mathematical law or axiom that states that I have to pick 2 to the left and 2 to the right. It's just a good number of points to get a good sketch of what's going on. All right. So again, personally, you could pick whichever one you want, but personally I would pick the top because those are easier numbers to work with, 1 and 2. A parabola is symmetrical though, so even if you picked 4 and 5, you'd get the same answers and you can just reflect it. So let's see. For this problem, I'd say f of 2 is equal to 4 times 2 squared minus 24 times 2 plus 27. 2 squared is, let's see what it is. 2 squared is 4 times 4 is 16. 16 minus 24 times 2, that's 48. 16 minus 48 is going to be negative 32. Plus 27 is negative 5. Whew, good mental math there. I almost had to break out the calculator, but we can do it. We can do it. Next point's at 2 comma negative 5. 2 comma negative 1, 2, 3, 4, 5. Next point, we plug in 1. F of 1 is equal to 4 times 1 squared minus 24 times 1 plus 27. Speaking of calculator, if you are ever uncomfortable with doing this, you could certainly use a calculator on an assessment. So, you know, you always have that to worry about, but it's always good to practice those mental math skills. I would say here 1 squared is 1 times 4 is 4. Minus 24 is negative 20. Plus 27 is positive 7. So my next point is all the way up here at 1 comma 1, 2, 3, 4, 5, 6, 7. I left barely enough room on my graph. Look at how steep that parabola is. That is kind of the consequence, though, of having the stretch of 4. A stretch of 4 means you're going to have this really tall shape. So it's nice that it fits on our graph. Now we can go ahead and mirror to the other side. Of course, it would mirror in the chart as well. We'd see we have a mirror image point here, same distance away from the vertex. Mirror image point here, same distance away from the vertex and the axis of symmetry. And we can draw our really, really tall parabola just like that. Ooh, that was a good parabola right there. You know, it's the simple things in life, and that was an awesome parabola. I'm very accomplished about that. You know, you got to take joys in the little things sometimes. I like that a lot. That was a great parabola. They're a little bumpy over there, though. But that's all right. Hopefully no question as to how that was done. Let's very quickly run through the characteristics as well. I would say my domain is all real numbers. Goes forever to the left and forever to the right. Any parabola will. Your range doesn't go down forever. It only goes down to -9, but it does go up forever because of those two arrows. It's -9 to infinity. Your axis of symmetry is x equals 3. That's the vertical line that would split your parabola in half. Always goes through the x-coordinate of the vertex, and that vertical line is given by x equals 3. All of these values have an x-coordinate of 3. Let's see. Next is our maximum or minimum value. This parabola has a minimum, so we'd say it has a minimum, a lowest value at f of x equals -9. Notice it doesn't have a maximum because it goes up forever. And lastly, the end behavior. It's going up on both sides, both as x approaches -infinity, it's going up, and as x approaches positive infinity, it's still going up. We'd say as x approaches -infinity, f of x is going up, approaching positive infinity. And as x approaches positive infinity, f of x also approaches positive infinity. Okay? So that is that. 2 examples done in detail for you. Hopefully it made sense as to how that process worked out. You saw one that had a negative stretch facing down, one that had a positive stretch facing up. I could change the numbers all I want, but every single parabola graphed in standard form will be done this same way. All right? So I am going to kind of end the video here, but I would like you to try one on your own. I'm going to trust that you do it. Here's the example I'd like you to do on your own. It's right up at the top there. F of x equals -1/2 x squared minus 4x minus 5. I'm going to ask you to pause the video now, see if you can try that problem on your own, and I'll reveal the solution in just a moment. So hopefully you paused that video, tried it by yourself, sketched a graph, created the table, found the vertex, did all the characteristics. Here's the answers. If you'd like to pause the video, take a look at the answers, please feel free to do so. But I am going to end things here. Thank you so much for your attention and focus today. Moving on, we're going to have our progress assessment and talk about how to convert between standard form and vertex form. Have a great day, everyone, and thank you again.